Okay, here we are, 1.4a in college algebra, and we're going to get into some kind of weird stuff. We're kind of getting into some pre-calculus kind of things, so good to learn these, and you'll go more in depth with these when you get into calculus, but it's just kind of getting your feet a little bit wet. All right, so one of the things that you need to know is if you know 2 points on a line. So let's say, for example, you know these 2 points. If you know those 2 points, you can write the equation of a line. Remember, the equation of a line, one of the ways you can write the equation of the line is that right there, slope-intercept form, y equals mx plus b. M being the slope, b being the y-intercept. All right, you can also write the equation of the line if you know 1 point and maybe the slope is 2/3. Okay, so if you know 2 points or 1 point in the slope, you can write the equation of a line. All right, so if we know the slope and the y-intercept, we can write the equation of a line. Okay, and so what we do is we use these 2 points or this 1 point in slope to find the slope and the y-intercept. Now, fortunately, in this one here, you're already given the slope, so you don't even have to find it. But if you're given the 2 points here, you have to use the formula to find the slope, which is the one y value minus the other y value over one x value minus another x value. And that will give you the slope. So if I'm looking at this one right here, it would be 6 minus 3, or 3 minus 6. It doesn't really matter which order you put those in. 6 over 3, or in negative 3 minus 1, or if you wanted to go the other way, 3 minus 6, we could do 1 minus negative 3. And so we get 3 over negative 4, or negative 3 over positive 4, which these are the exact same thing. It doesn't matter if the negative is on the top number, the numerator, or on the bottom number, the denominator. It doesn't matter. Okay? One negative on a fraction makes the fraction negative, and it doesn't matter if it's there or there. Okay? So you get to choose. But so anyway, the slope is the same. See, we took the difference in y's, the difference in x's, and we got the slope, which means it can plug in there, and then all we have to do then is find the y-intercept, which is what we're going to do later on. All right, so example number 1. Let's see if I can erase this whole thing. Yep, in one fell swoop. An appliance repairman charges $60 for a service fee. So he shows up at your house, it's $60. And then as long as he stays at your house, it's $25 an hour on top of that. So it starts at 0 time, it starts at $60 an hour. Okay, so that's where we start there. Let's do it in black. And then the price goes up. So let's go 1, 2, 3, 4 hours, and every $25. So every hour it goes up and up and up, and see how it makes a line. It's a linear equation or a linear function. Because $60 is the basic charge before any time is spent. $60 is the y-intercept. It's where we start at time 0. Okay? And so we can write the equation of this as y equals $25 times how many hours you take, he takes, plus the y-intercept, which is 60. Okay? This number here is the slope. That's how far you go up each hour. The x is the number of hours. So 25 times 2 is 50, plus 60 is 110. So at 2 hours, we should be up to $110, which looks like we kind of are, doesn't it? Because even though I've got this really nasty looking graph that isn't real fancy and pretty, I've got 60 plus 25 plus 25. So when I get to 2 hours, I'm at that point right there. Okay? So the key here is learning how to write the equation of a line given a bunch of material, just like we did in this one with the dollar amount. Okay? So we next consider a form of an equation, get rid of all this again, that can be written if we know the slope and a point. So remember I said if you know 2 points, you can find the slope and you can find the y-intercept. Now we're going to look at a form of an equation of a line that can be written if we know a slope and the point. So if the slope of a line is m, I'm reading at the top of page 60, then the slope between a fixed point, x1 and y1, and any other point on the line is also m. Okay, that means, and basically what they're saying is y minus y1 over x minus x1. Okay, we have 2 points, we can find the slope of that line. So up to this point, I've shown you the slope-intercept form of an equation. We also have a different equation that basically is that equation, only it looks a little bit different, and it looks like this. Okay? And that is called the point-slope form of the equation. Okay? So, what this is when you know the slope and you know one of the points, you can use this equation in order to solve it. When you know 2 points, you can use this equation. Now, don't get me wrong here. Don't get confused. You can use either one of these. It's just one is easier to use than the other depending on the information that you are given. And I'll show you how you can use both of these later, or either one, so you're not stuck with, oh my gosh, which one do I use here? It doesn't matter. You're going to get the right answer. All right, so example 2 says, write an equation for the line that passes through point. Okay, let's move this out of here. It passes through point -1, 5. I'm sorry, I'm out here at a picnic table in the wilderness with my golden retriever puppy, and I'm kind of distracted a little bit as she's kind of wandering around in the woods here. So she's right here beside me now chewing on a big log, so I think I'm okay for a little bit. All right, so write an equation of a log. Write the equation of a line. All right, we're given a point and we're given the slope, so we're going to use the point-slope form. Why is it called a point-slope form? Because you're given a point and a slope, so you use the point-slope form. What I would do is I would put this in your notes and call it point-slope form. And then when you're given a point and a slope, you know you're going to use this equation. All right, so not really too difficult. So we are going to call this our x and this our y, obviously. And let's go ahead and plug some numbers in. Y minus 5, so we're going to take that y there, equals our slope, which is 3/4. It doesn't look like a 4, does it? All right, try it again. Times x minus -1. Okay, so let's just rewrite this real quick. Y minus 5. I don't like all these negatives here. So we get that. Let's go ahead and distribute that 3/4. Okay, we're going to add 5 to both sides. Plus 5. Okay, let's move this up a little bit. And we end up with y equals 3/4 x plus 23/4, because 5 is going to be 20 over 4, and then we add our numerators and get our 23. All right, so there you go. We just wrote that equation that we started with in slope-intercept form. Okay, that's the equation of a line. And then you can graph it without any problem because, if I can get myself a graph, because we know it crosses at 23 over 4, crosses the y-axis. 23 over 4 is, gosh, what? 5 and 3/4. 1, 2, 3, 4, 5 and 3/4. So it crosses there. And slope is y over x. So if y is 3 and x is 4. So that means we go over 4 up 3 from this point here. Over 1, 2, 3, 4, up 1, 2, 3. We get that. Draw our straight line, and there we go. So are you seeing how all this stuff fits together? Okay, maybe not, might take a little bit, but let's jump down to example 4. You can look at example 3 on your own, but example 4 kind of goes into what I had said earlier about the idea of being able to use either formula. So let's go ahead and use both formulas for example 4. They give us a point, and they give us another point. And what they're interested in is the equation of a line. Okay, I can use my y minus y1 equals m times, I have to think there for a minute, x1. And we get y minus 5 equals our slope, and then we've got x minus -1. Okay, so what I did is I just used this point here. Okay, it doesn't matter which point you use, you just grab one of the points, and using the point slope form, you write it that way. But one thing we didn't do is we didn't find the slope. Slope equals the difference in my y values, 5 minus 4 over difference in my x values, -1 minus 2, so that gives me 1 over -3, or -1/3. Okay, so we get y minus 5 equals -1/3 x minus 1/3. Then we add 5 to both sides. So we're going to add 5 to both sides, which is 15 over 3 minus 1 over 3 is 14 over 3. All right, so this is using the point slope formula. Okay, so this is all point slope formula. Let's do the same thing, only this time let's use the slope intercept form. Y equals mx plus b. All right, so y equals -1/3 x, because that's our slope, we already found that, plus b. Okay, so what are we looking for? We're looking for the y-intercept. You cannot write a linear equation unless you have the slope and the y-intercept. So we've got the slope, now we're going to find the y-intercept. So what we do here is we pick either one of these points. It does not matter which point we use. I like using the 2, 4 here because there's no negative. So let's just use that one. So I'm just going to put the 4 in for the y here, the 2 here, and so I'm solving for the y-intercept, because once I find the y-intercept, I'm done because I have the slope. So 4 equals -2/3 plus b. Add 2/3 to both sides. Again, all I'm looking for is the y-intercept. So that would be 12. 14/3 equals b. Now, that's what I found here, right? So now I have y equals -1/3, that was my slope, x plus 14/3. All right, so again, all I was looking for is my y-intercept and my slope. Once I have that, I just write it as y equals slope x plus y-intercept. So I can do this method, or I can do this method. You can use either or, okay? If you'd rather just use one because you don't want to be messing with formulas, that's fine. But see how I could use either or, so it didn't matter which one I used? So that always makes life a little bit easier. All right. Let's call this 1.4a done, and we'll start on 1.4b.